Hello everyone over there, my dear students. So today I came up with another topic, and this is going to be very important topic for 11 and 12 students if are there. Okay. Yes, today I'm going to discuss about the Markovnikovs rule, right? So I'll explain what is Markovnikovs rule and how to apply that Markovnikovs rule. So watch the video till the end. So let's start. Markovnikovs rule. Yes, where in which topic will you get this rule? Yes, that is the first question. Yes. So we'll apply this rule for the alkenes. Yes, for the alkenes. Right? So you know what are alkenes? Alkenes are the unsaturated hydrocarbons. Okay, alkenes are the unsaturated hydrocarbons. Right? So they are unsaturated hydrocarbons. They have a common formula of CnH2n, right? And here what is very important is that a double bond between carbon and carbon, right? So this rule is applicable for alkene, right? Now what type of alkene we will apply this rule? That is the second point. This rule is applicable only for the unsymmetrical alkenes. Yes, this is applicable for unsymmetrical alkene, where say this type of alkene we can apply this rule. Okay, so where double bond is there, odd type of alkene, where number of carbons are odd in number, right? So that is unsymmetrical alkene. Let me show you what is the difference between the symmetrical alkene. Now suppose if I take this is a symmetrical alkene, right? Okay, if you take this type of alkene also, my dear student, that is also a symmetrical alkene. Okay, because if you do the IUPAC nomenclature, if I put this double bond here also, the same name will come, which means this is also a symmetrical alkene. So we will not apply Markovnikovs rule on these type of alkenes, right? Rather, we will apply Markovnikovs rule where? For the unsymmetrical alkene. So this is a very important thing. Okay. So we will apply this rule for the unsymmetrical alkene. Now, in which type of reaction we are going to apply? Yes, that is also very important thing. We apply this rule when we react or add HX type of molecules. Okay, when we add or react HX type of molecules or compound. Okay, so that is hydrogen halide type of molecules, right? And the fourth important point is that the order of the reaction. Yes, if we are taking X as the halogen or the nucleophile here, then what is the order of the reaction for the halogen? So that is very important. The order is, first is hydrogen iodide, then hydrogen bromide, then your hydrogen chloride, okay, and finally hydrogen fluoride. So this is the order of the reaction. Okay, so this also we need to keep in our mind. Okay, so Markovnikovs rule we will apply for alkenes. What type of alkenes? Unsymmetrical alkenes, where basically we show the addition mechanism or addition of HX type of molecule. Okay, HX mean HI, HBr, HCl, HF, this type of molecule, and the order of the reaction is hydrogen iodide greater than HBr, then HCl, and then we have finally HF. Okay, so these are few important things. Now let us move on to the Markovnikovs rule. Okay, so let us move on to the Markovnikovs rule. Now suppose you know that whenever we go for any type of reaction with the unsaturated compound, they go for addition reaction, right? They go for addition reaction. I mean, whatever you give to them, they add up, right? So let me give a simple example. Say if I take a simplest alkene, this is ethene, right? So what will happen if I add, say if I add a reactant, say AB, So what will happen? right? So it will add up, right? It will add up because you can see that these compounds are unsaturated. So what it will do, it will simply, this double bond, this is pi electron, you know, pi electrons are very loosely held. Pi electrons are very loosely held, okay? So they can be easily, we can break them, right, into single bond, right? So these pi electron can be broken into single bond, and here an addition reaction will go. So we will add up A and B. But my dear students, see, this is for the symmetrical, but how to add if there is an unsymmetrical, right? If the alkene is unsymmetrical, yes, here we apply the rule. So let's see. Okay, so I hope you are taking down the notes, right? Now what will happen if I write this type of reaction? Say I have taken 1, 2, 3. Okay, so what is this? Yes, this is, if I start numbering from here, 1, 2, 3, meet it probe. So probe 1 in, right? So this is propane or probe 1 in. Okay, you have taken. Now let me keep the hydrogen also, because these are very important. Here the role of the hydrogen is very important in this rule. Okay. Okay, so I have already completed giving the hydrogen. Now imagine that I have to add HBr, hydrogen bromide, with this. Okay, now if you add hydrogen bromide with this, there can be two possibilities, right? Where to add hydrogen and where to add bromine, isn't it? Where to add hydrogen and where to add bromine, because if this double bond is, if we break this double bond, then the possibility is that both of these carbons are unsaturated. You can see that both of these carbons, see, look at this carbon, the first carbon and the second carbon, both are unsatisfied, both are unsaturated, right? Which means both requires atoms, both require electrons, right? The question is that then where shall I add this H and where shall I add the Br? Okay, so here Markovnikovs rule shows us how to add on. Okay, so see, there can be two possibilities. Now what are the two possibilities? The first possibility is that the hydrogen can add here. See, the second carbon, now I am writing here, you see CH3, okay, next CH, and then I am adding H over here. Okay, another possibility also I will show HBr, right? So this is one possibility. Another possibility is that it can also form this type of compound as well. Okay, CH. Now this time this Br can get added with here, Br, and then finally H, right? Yes, these are the two possibilities. These are the two possibilities. Now Markovnikovs rule says that, now very important, according to the Markovnikovs rule, it states that the negative part of the addendum get added to the carbon having less or minimum number of hydrogen atoms. Okay, that's it. Okay, so the negative part of the addendum get added to that carbon having less or minimum number of hydrogen atom. Yes, we need to understand. Now my dear student, what is the meaning of addendum? Addendum means which get added up. So here you can see that HBr is getting added to this, right? Nothing is left as any byproduct, right? So it is getting added up to this molecule. So it is known as addendum. Now what is the negative part? Okay, so for that we need to break up this molecule of HBr if we split it up, we will get H plus and Br minus, right? So which is the negative part here, my dear students? Br minus is the negative part. Now what is the role of the negative part? It acts as a nucleophile. Okay, already you have learned the basic chemistry, so it is known as nucleophile, right? Because it is having a negative charge. So they act as a nucleophile, whereas these act as a electrophile, right? They act as a electrophile, right? So what are nucleophile? Nucleophile mean nucleo, which are getting attracted to the nucleus. Now what is the charge on the nucleus? Plus charge. Phile mean it came from tendency to attract, love, tendency to get attract. So the species which get attracted to the nucleus or the positive charge, they are known as nucleophile. Yes, they are the negatively charged species or electron rich species. Whereas the species which are deficit of electrons, okay, I mean they get attracted to the electrons or the negative charges, they are known as electrophiles, right? Now what does this rule says? This says the negative part of the addendum get added to that carbon having less or minimum number of hydrogen. So if I follow this rule, then which among these, which product should be maximum stable, right? You see here, look at here again. Okay, which carbon is having minimum number of hydrogen? 1, 2, 3. You see the second number or the second or the middle carbon is here having minimum number of hydrogen, which means the negative part will be added to the minimum number of the carbon which is having minimum number of hydrogen, which means this is more stable. This is more stable. So according to Markovnikovs rule, we will always add the negative part of the addendum with that carbon which is having minimum number of hydrogen, or you can say which is maximum substituted, right? So here you can see that this product is more stable. That is why in this reaction you will get 80% or major product will be your this compound. Now what is the name of this compound? 1, 2, 3, do the nomenclature. 2-bromo, so here I am writing it here, 2-bromo with it prop, so propane, 2-bromo propane is the name of this compound, right? Now what is the name of this compound? 1, 2, 3, 1-bromo propane, right? It is the name of this compound. So hope you understood, yes, the rule. Okay, hope we have understood the rule. Now I will also explain the mechanism of it. Okay, so once again I am telling that what does this rule says? The negative part of the addendum, okay, will get added to such carbon which is having minimum number of hydrogen. Okay, so that's the rule. Now let us go through the explanation and the mechanism why it is happening. Okay, why should we go for such type of products? Okay, so let's see the scene behind. Okay, so for that we need to understand the mechanism, isn't it? Okay, so the mechanism is very simple. Okay, in very simple way I am going to tell you. So see, you know, the pi electron, they are loosely held. Okay, so here once again I am writing that propane. Okay, so hydrogen I will put in the last, right? So here you see these are the pi electrons. So now I am going to discuss the mechanism of this reaction. Okay, so very important students. Okay, please pay attention and understand. Okay, so you know this pi electron, they are very unstable. Okay, they don't want to stay in one place because both are negative charge, and what will happen if you bring two similar charges close to each other? They will repel, they will fight with each other, and they want to move here and there. So similarly here this pi electron is very much unstable or loosely held. Okay, so what will happen? It can move here and there. So once it can move to this carbon, the first possibility is that, okay, that C, if this electron moves on this carbon, you see, then a negative charge will develop on this and a positive charge will develop on this carbon, right? Another possibility is also there. What is the second possibility? That this pi electron will shift toward the inner carbon, right? Which means the second carbon here. So in that case, what we can expect, that the negative charge will come on the second C, and the positive charge will come on the terminal carbon. Now, what is this known as? These are known as carbocation, right? They are known as carbocation. Yes, so this is carbocation. You know, this is also carbocation, right? Okay. Now, here we need to understand the logics, right? So, which carbocation is more stable? We need to understand which carbocation is more stable. For that, you should know that the carbocation, the stability of the carbocation, it follow the order 3 degree, then 2 degree, then 1 degree, right? I am showing you. Suppose you have a carbocation plus charge like this, okay, is having a carbocation which is having the degree, say 1 degree, okay, you have given like this, and say 2 degree carbocation, okay, this is 2 degree, right? And say you also have a 3 degree carbocation, say this is 3 degree carbocation, okay, so this is your 1 degree, 2 degree, and this is your 3 degree, right? Now, which carbocation is more stable? This carbocation is more stable, which means the degree of carbocation increases with the degree of the stability, right? So, which means here 3 degree carbocation is more stable than 2 degree and then 1 degree. Now, let us write the degree of this carbocation. For this, here you see, what is the degree, my dear students? You just see, this carbon is attached to another carbon. So, how many carbon is it attached? Only one carbon. So, what is the degree of carbocation here? 1 degree, right? Now, in this case, you see this carbocation is getting attached to two carbon. So, what is the degree of it here? 2 degree. Now, you only apply your sense that which is more stable. You got your answer? Which is more stable? Yes, obviously this is going to be more stable. Okay, so this is one part of the mechanism. Now, let me go to the addendum part. Okay. Now, what about the addendum? Okay, suppose I am taking HBr over here, I have taken, right? So, HBr, you see, I split it into H plus and Br minus, right? Now, you see, Br minus is having excess of electron with a negative charge, right? And this C plus wants electron, right? Because it is having a plus charge. So, obviously, this Br minus will attack to the carbocation. Understood? So, Br minus will attack to the carbocation, which means in this case also Br minus will attack here, and in this case Br minus will attack here, right? So, that is the second part. And H plus, so where this H plus will go? H plus is having positive charge, right? So, obviously H plus is going to attack to the, yes, the negative part, that is the carbanion. So, here this part H plus will attack, right? Now, you only decide which one is more stable. Yes, now I hope all of you have understood and got the answer. Okay. See the degree of carbocation. Look at the degree of carbocation. This carbocation is more stable compared to this, right? So, which means my major product is this. Yes. So, Br minus should approach to the second degree carbocation instead of 1 degree carbocation, which make it more stable. Understood? Okay, that's it. That is only the Markovnikovs rule. Now, you can put on the hydrogen. Okay, with hydrogen you can understand that if I put on the hydrogen over here, so that is the reason you see both of the products are being formed. Okay, but the major is this product. Why it is major? Because the degree of carbocation supports it. It gives a more stability to that product. Okay, so Markovnikovs rule also says that only, that if the carbon which is having minimum number of hydrogen will attract what? The negative part of the addendum. So, the negative part of the addendum will go to that carbon which is having minimum number of hydrogen, or the degree of carbocation is more, right? So, finally, what will be the answer? Yes, if I write CCH, so how many hydrogen? 1, 2, 3. Okay, see, look at it. This is having the minimum hydrogen, and here 1, 2, 3, 1, 2, 3, 4. Okay, you add on HBr. So finally, the product we will write by Markovnikovs rule. We will write HH here, and here you will write H. Now here I am going to add the Br. This will be the major product. Okay, and the hydrogen will shift to the terminal carbon. So which means this follows the Markovnikovs rule, right, to support the maximum degree of carbocation. Okay, so this will automatically become the major product. This automatically become the major product. Okay, understood all of you? Hope understood? Clear? Now Markovnikovs rule. Now take any of the radicals and try to add it on with the help of the Markovnikovs rule. You will have the same thing. Instead of HBr, if you can take any of the radicals, say if I take water also, H2O, then also I will split it as H plus and OH minus sign. So here the nucleophile will attack to that carbon where the degree of carbocation is more. So that's simple. Okay, so you can apply this Markovnikovs rule to such type of hydrocarbons which are unsaturated, having double bond and unsymmetric. Okay, so hope all of you understood the Markovnikovs rule. So thanks for watching. Take care. Bye bye.